Yeah. Fish. Uh, Good day. Good day. Uh, this is a hot Monday. It's a hot Monday. It's a hot Monday. Eh. Yeah, it's a hot Monday. Please like the live and share the live and follow the live. Ne? So, actually, let me not title this as forces at equilibrium. I want us to start basically with the first law. Right? Let me. Right? So, I want us to focus on Newton's first law. Right? And in Newton's first law, obviously, guys, the one thing that we have to familiarize ourselves with is different types of forces, right? You have to be familiar with different types of forces, contact forces and non-contact forces, right? So, since first law, what do we understand about first law? Everyone? Writing on the bodies. Is the topic complete your statement there, my friend? I feel like you got limited by the comment section. Don't worry. Complete the topic, the topic that you what, but you will complete. I'll be waiting for you. Then, what do we understand about the first law? Hola, Steve. What say, my friend? You're good, man. So, let's do first law. First law. One. So here, guys, we are talking about F net being equals to 0 and acceleration being equals to 0, right? Because remember, whenever we are talking about F net being 0, it means the acceleration being 0, right? And again, we are talking about what? Constant velocity. The velocity is constant, right? Let's remind each other, how do we calculate for acceleration? And I want to confirm this thing of the constant velocity. Let's say an object, it is traveling at the constant velocity, right? It means as time goes by, the velocity, it doesn't change. Let's say our velocity is 3 for an object. And let's say our velocity is 3, and as time goes by, the velocity doesn't change. How do we determine velocity? Obviously, acceleration, obviously, we have to, I will say acceleration being a vector quantity is going to be the change in velocity over the change in time. So who can tell me what is the change in velocity here? What is going to be the change in velocity in this case? What's going to be the change in velocity? What is V final minus V initial? Right? Let's say my time is 2, 4, 6, and 8. And the velocity, it doesn't change. It remains 3, 3, 3, and 3. Very good. The change in velocity is going to be 3. 0, sorry. It's going to be 0, right? Because of why? If I were to calculate, the change in velocity is going to be what? My V final is going to be 3 minus 3 over, maybe let's say, I want to determine my acceleration between, let's say, 0 and 8. And 8 minus 0. Then I'll have what? I'll have 0 divided by 8. And my acceleration is going to be 0. Right? And check this out. If my acceleration is 0, guys, if my acceleration is 0, what is going to be the F net? Because remember, F net is going to be equals to ma, but my acceleration is going to be 0. So if my acceleration is 0, what about the F net? Are we going to have a value on F net if we got the acceleration to be 0 there? Are we going to have a value there on F net? Thank you. Thank you. Thank you. Our F net is going to be 0. Why is it 0 for those who don't understand? It's because, like, if we are having our acceleration to be 0, it means I'm going to have what? M and 0. And what is M multiplied by 0? It's going to be 0 newtons. And what does F net equals to 0 tell us about the forces? What is F net equivalent to 0 tells us about the forces. Physics it has footsteps. Says, what does F net equals to 0 tells us about the forces? Only one weight, Inji. You only need one weight. Yes, it means all the forces are balanced. You get it? All the forces are balanced. You get what I'm trying to say? If, in a nutshell, if the object it is moving at constant velocity, it means acceleration is going to be 0 and the F net is going to be 0, right? So if the object is moving at constant velocity, I want to ask you, let's say the object it is moving at constant velocity, this object M, and I'm pushing this object with a force applied which is equivalent to 30 newtons, and on a rough surface, of course, what's going to be the value of the friction since the object is moving at the constant v of 3 meters per second to wherever direction that what's going to be the value of friction here? What's going to be the value of friction? Thank you very much. It means the type of the friction that is going to oppose this force applied is going to be 30 newtons. But what is the difference between this 30 newtons and 30 newtons? Both of the frictions, they are going to be 30 newtons, but in different direction. Do we understand each other? Do we understand each other so far? Do you understand each other? It means the F net is going to be equals to 0, right? So it means, by confirmation, if the object is traveling with the constant velocity, just know that the acceleration is going to be 0. And if the acceleration is going to be 0, it will cause the net force to be 0. And what do we know about the net force being 0? It means all forces are balanced. Simnandi. It means all the forces are balanced. Or you can say all the forces are at what? Equilibrium. Or all the forces are at equilibrium. Right? So, what if the object is traveling at constant velocity and I'm pushing this force at that angle, and this is going to be 30 newtons, right? And let's say here my at an angle of 30 degrees. What's going to be the value of this frictional force here? What's going to be the value of this frictional force? Is it going to be 30? Yes or no? Is it going to be 30? The value of the friction that we are going to have there is going to be 30. Is it going to be 30? Why is it not 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 30? It's because this force and that force, they are not in the same straight line. They are not collinear vectors. It means, what is it that is going to be equivalent to friction? What is the force that is going to be balanced by that frictional force? That is going to balance with that frictional force. What is going to be the force that is going to be balanced by that frictional force? Testa or go sekolong la di tshwara dilo tseo. I want to know, yes, they are not in the same plane. As me and you, we confirmed that this force, it cannot be 30. So I want to know, Hore, if the object it is traveling at the constant velocity, I need the name of the force that is going to be balanced by frictional force so that it causes the object to move at constant velocity. It's going to be what? It's going to be Fx. It means this force is at an angle. It means we have to figure out our Fx. The Fx, it is collinear. It is on the same straight line with frictional force. I'm emphasizing this because there are some people, they will just confirm. Because these people here, they will just say this 30 newtons is going to be equals to the frictional force, and of which is something that is not correct. You have to determine the x component of f. So please, can you please get the x component of x, the x component of x? How do we get the x component of f? Let's do first, Nyana. What's going to be the x component of f? Because obviously, I'm going to draw my tail to tail or my head to tail, and get my tail to tail or my head to tail. So I'm going to draw my 30 newtons, right? And obviously, I'm going to have my Fy pointing downwards, and I'm going to have my Fx pointing to the right, and I'm going to have my 30 degrees to the right. So I'm going to have this as the F applied. Then how do I get, which trig ratio am I going to use to get the Fx? Which trig ratio am I going to use to get Fx here? So that I can get the x component of F that is going to be balanced with frictional force. What's going to be the trig ratio? Obviously, it's going to be cos, right? Because of according to Socrates. This is the one that qualifies because of why? Cos theta is going to be adjacent over hypotenuse. So I'm having my Fx, I'm having my Fy. Then what is the adjacent sine of 30? What is the adjacent side of 30 newtons? Can someone tell me what is the adjacent side of 30? What is the adjacent side? It's going to be Fx, right? These are simple trig ratios that you have to learn. So it means what I'm going to say, cos 30 is going to be Fx over, what's going to be my hypotenuse? I need the value of the hypotenuse. No check maths and no. Maths or how? What is the value of the hypotenuse now? It's going to be the F applied, right? The F applied is going to be the value of the hypotenuse. Then what's going to be my Fx? My Fx, obviously, whenever I'm solving for Fx, I'll just multiply this 30 cos 30 degrees and that 30. If I multiply them together, what do I get? I'm going to get what? Cos 30 degrees multiplied by 30 is going to be 25,98, right? 25,98 newtons. In which direction? Remember, our vector quantity, it's in, like the force is a vector quantity. What's going to be the direction of this vector? What's going to be the direction of this vector? Obvious. What's going to be the direction of this vector? Thank you very much. It's going to be right. Right? Now, what's going to be the value of friction now, since we got Fx? What's going to be the value of friction? What's going to be the value of friction? Friction. I need the value of the friction. What's going to be the value of friction? You don't listen. What's going to be the value of friction? Thank you. So it's going to be 25,98. In which direction? Newtons. In which direction? Thank you. It's going to be the same amount. So in which direction? Yes, you can say west or you can say left. So why is it the same value? I want to check whether you've listened or you were not listening. Why are these two of the same value? Why are they having the same value but in different direction? Why are they having the same value here but in different direction? Why are they having the same value but in different direction? Why? Why? What about constant? I don't know. What about constant? What about? I want to know why is F and Fx? Why is the friction? But when you say constant, I don't understand what are you saying. You have to say the object is moving at constant velocity. But sometimes they can tell you a constant force. The constant force is applied. Which constant are you talking about? Yes, it means all the forces are balanced because of why the object it is moving at the constant velocity. Do you get that, right? So let's do some activities now. Let's do some activities. We talked about now. So I want us to focus on the forces at equilibrium. Ne? All right. Ne? Right? Then Here they just said F3, which is 600 newtons. Ne? So they're saying the force on an object. Okay, they're saying all forces are at equilibrium. Ne? And now the question is said, they're saying the question, determine F. Yes, that's the question. We have to determine the value of X. Hey guys, no, tap the screen. Can you please tap the screen? Please like the live, guys. Let's get to 5K. Please. Let's like the live, guys. Let's like the live. Because like the least you could do is to tap the screen. Why one? Yeah. Thank you very much for the gift. God bless you. So now let's talk about this. What is it that we have to do here? Let's talk about this. What is it that we have to do here? Yes, it can be possible. It can be possible that the normal force is equals to the Fg. Who can tell me what would be the reason for this normal force to be greater than frictional force? What would be the reason? What would be the reason for normal force to be greater than Fg? We have to determine F. What would be the reason for the normal force to be greater than Fg? No one knows. What would be the reason? There is a possibility that normal force to be greater than Fg. There is. Please tap the screen, guys. I need 5K. I'll respond to this question when I'm at 5K. Because you don't tap the screen. F is pulling the object upwards. Is F pulling the object upwards? No. It is not pulling. It is pushing downwards. Down the incline. It is pushing the object downwards, but at the same time to the eastwards direction. You get it? F, it is pushing this object to the eastwards direction. Now, I want to ask you a question. Why would, in which case would this be possible? Where you get the normal force to be greater than Fg? In which case would you get the normal force to be greater than Fg? Before I respond to the question, you have to answer me here. But today, it's not the mass. At an incline, what is it? What is it that is at an incline? I don't want half answers. Be serious and type something that I understand. Angle of what? I don't see an angle. If you say an angle, even this one is an angle. It's an angle of the block. It's an angle of the block. I don't know what you are talking about. I want you to respond in such a way that everyone would understand you, to show that you are confident with your answer. Type more. So, okay, since you didn't tell me, let me tell you again, guys. So as you can see there, we are having an F pushing this object down. You get what I'm trying to say? Check this out. You get it? So if we are having an object being pushed by this applied force at a certain angle, right? So will we have the components of this force? Who can tell me? Is it a yes or no? Are we going to have the components of these forces? Yes or no? Are we going to have the components here? Are we going to have the components? Thank you very much. Please name those components. Please name those components. Yes, we are going to have the components. You are very correct. What are the components that we are going to have here? Obviously, components are always going to be fx and fy, right? Fx and fy. Thank you very much. Thank you for the confirmation. So let's start with fx. Fx is going to be in which direction in this case? In which direction are we going to have our fx? In which direction are we going to have our fx? To the right, guys. Thank you. We are going to have our fx to the right. Our fx is going to be to the right, right? So what about fy? Fy, is it going to be upwards or downwards? Our fy is going to be upwards or downwards? It's going to be upwards or downwards? Hey! 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 Which one is which? Hey, Lele Madoda. Upwards, downwards, upwards, downwards. Hi, Bafito. Okay. Bon. Bon, Ane. There's a picture, maybe. Or maybe there's a, I don't know. There's something that you are pulling on top of the wardrobe. Ne? On top of the wardrobe. And here is you. Using a rope. Ne? And as you are using the rope, ne? You are pulling this object towards this direction. Tell me, since you are using the rope to pull this object towards that direction, is this force going to have components? Yes or no? Let's start there. Is this force going to have components? Yes or no? Let's start there. I need you to understand this before you answer here. Will this object have components? Yes or no? It will, right? Now, I'm interested to the direction of fx. Where is fx going to go? Is fx going to go to the left or to the right? Left or right? Fx here. Thank you. So the fx is going to go to the right. Right? So what about fy? Is fy going to go upwards? Is fy going to be in an upwards direction or in a downwards direction? Is it going to be upwards or downwards? It's going to be downwards. Anger. Thank you very much. It's going to be downwards. So why do you say it's upwards here? Because of, as far as I know, this and that are in the same direction. Are you still saying fy is going to be upwards here? Are you still saying fy is going to be upwards here? Are you still saying that fy is going to be upwards here? Yes or no? Yes or no? Thank you very much. Fy is going to be downwards. Pela, this direction, guys, means I'm going downwards, but at the same time I'm going to the right. Right? What about this direction? What about this direction? My fx is going to which direction? Here. Is it going to the right? Is my fx going to the right? In this direction? Thank you very much. My fx is going to the left. But my fy still downwards. Do you see that? Last one. What about this one? What about this one? Where is my fx and my fy going? Where is my fx and my xy going? Thank you very much. Or you should ask yourself Simple question. Where is it pointing this thing? Is it possible for this thing to point to the right? No, it points to the left, right? It is pointing to the left. Is it possible for this thing? Can you say this thing is pointing up downwards? No, it is pointing upwards. Why one? Don't buy it. Don't buy it. Skyra the mistake. Why? So going back to this scenario where we're going to have the normal being greater than fg, right? I'm going back to this scenario where we get our normal to be greater than fg. Like, it's because of this force, right? This force is the one which causes the fg to be less than normal. Why am I saying that force? Ne? Obviously, along the vertical direction, what's going to be my F net? Along the vertical direction, what's going to be F net? Since the forces are at equilibrium, what's going to be the F net along the Y? What's going to be the F net? What's going to be the F net, guys? Along the Y. Along the Y. I need the F net along the Y. F net, the resultant force, is going to be 0, right? Because of the forces are at equilibrium. And along the Y, the F net is going to be 0, right? So check something. I'm going to have my Fy pointing downwards, right? So let me choose downwards as positive. I'm going to choose my downwards force as positive, right? I'm going to choose my downwards force as positive. So let's determine the resultant along the y-axis. Since I chose downwards as positive, is Fg going to be negative or positive? Is Fg going to be negative or is it going to be positive? I'm determining the F net now. Thank you very much. So it means my F net is going to be F1 plus F2 plus Fn, right? But at the same time, 0. My F net is going to be 0. But at the same time, I'm going to have my Fg to be positive, right? And what about my normal? Is my normal going to be negative or positive? My normal here, is it going to be negative or positive? Is my normal going to be positive or negative? Normal. This guy here. Guys, we chose downwards as positive. We chose downwards as positive. We chose downwards as positive. Is this guy going to be negative or positive? We chose downwards as positive. Is that guy going to be negative or positive? Guys, what's going to be this guy? Is this guy going to be negative or positive? I won't give you the answer. Forget. Manchaloy. Can't the guys? Okay, let me change the direction. Let me change the direction. I choose upwards as positive. Is Fg going to be positive or negative? Is Fg going to be negative or positive? Don't be afraid. Guys, boy, don't be afraid to participate. If you participate, you are doing it for yourself, guys. You are doing it for yourself. You have to understand. If you don't understand the direction, you should say, I don't understand the direction. Or you should try your luck, or negative, positive. If you get wrong, you got wrong. Next time it means, if I point upwards as positive, this point is pointing in an opposite direction, downwards. It means, if I chose that direction as positive, this becomes negative. This guy is pointing up. It means it's going to be positive. What about Fy? Is Fy going to be positive or negative? Is Fy going to be positive or negative? Thank you very much. Fy is going to be negative, right? So let's write it down. So this f net is going to be 0. Now we are going to have this guy being chosen to be positive. It means that my Fg is going to be negative, and my normal force, since you said this guy is going to be positive because he's pointing in the same direction as that guy there. And get, so I'm going to say normal to be positive, and Fy is going to be negative. Fy. Y1. So you can see that if I take everything to that side, right? If I take everything to that side, so I'm going to have Fg plus Fy is going to be equals to n. So it means that 600, it's going to be Fy plus Fg, which is going to be equals to n. That's why your normal force is greater than Fg there. Do you understand what I'm saying to you? Because of this force Fy and Fg, they are pointing in the same direction. So the sum of the two, they are going to give you the normal force. That's why we get the normal force to be greater than Fg, because of the normal force is the sum of this force of gravity and that normal force. Not every time normal force will be equivalent to force of gravity, not in all cases. More especially in a case like this. Not in every case the normal is going to be equals to the force of gravity. So now I'm going to replace the values now. Because of I want what? The value of Fy, so that I can get that F. I need Fy there. So what am I going to do? The value of Fg is going to be 500 plus Fy is going to be equals to 600. Then what's going to be the value of my Fy? What's going to be the value of Fy? Thank you very much. It's going to be 100. Right? It's going to be 100. And in which direction? It's going to be, Fy is going to be 100. In which direction? Let's talk about the direction. In which direction? Downwards. Right? Now, let's talk about Fx now. As we talked about the Fx on the previous when we were talking about the Newton's first law, and let's talk about the Fx now. So Fx is gonna be in which direction? Let's remind each other now. Fx is going to be in which direction? In which direction are we going to have our Fx? It's going to be right. It's going to be right because of, you can see our F there, it is pointing towards the right. It is pointing towards the right. It's going towards the right, not to the left, to the right. So our Fx is going to be equals to right. Right? It's going to point to the right. So do we have to determine Fx here? Do we have to determine Fx? Who can tell me? By your observation, what's going to be the value of Fx? What's going to be the value of Fx? Or do we have to determine it? What's going to be the value of Fx? Why Fy downwards? Because of the F. Okay, let's check this F. Is F going towards the downwards direction or towards the upwards direction? By looking at it, just move your hand You can see what I'm doing. I'm going down. We are going down due to this force. And at the same time, am I going to the left or am I going to the right? Am I going to the left or am I going to the right? It means, am I going to the left or am I going to the right? According to the force. I'm going to the right due to this force. Do you see that? Now you understand why downwards. And get, just follow the arrow and just try and move your hand. Oh, it means it's going to go downwards. Move your hand again. It's going to the right. But one simple concept. Let's get confused, guys. So, some of you are saying fx is going to be 200. Why is it going to be 200? Why do we say that fx is going to be 200? It's because all the forces are at equilibrium. So it means the sum of all the forces. Thank you very much. Right? Thank you very much. The sum of all the forces. Right? The sum of all the forces. The sum of all the forces. The sum of all the forces. F net is going to be equals to 0. So it means if I choose that direction as positive, guys, F2 is going to be positive or negative? Is F2 going to be positive or negative? Is if I choose right to be positive, F2 is it going to be positive or negative? Negative. And get throw a negative F2. So it means I'm going to say what? I'm going to say F net. Okay, wait. So since F net is going to be equals to 0, I'm going to say 0 is going to be equals to Fx. Oh, my Fx is going to be positive or negative. Sorry about that. My Fx, this Fx, since you told me that it goes to the right, is it going to be positive or negative? Fx. Thank you. It's going to be positive. Plus F2 you said is going to be negative. Right? Let's move this thing here. Then what am I going to say then? Going to say 0 is going to be Fx minus 200. Then my Fx is going to be 200 newtons. In which direction? 200 newtons in which direction? Left or right? You said it. Left or right? Right. Physics is monate, guys. The easiest subject in the world. So now check this out. You have your Fy to be 100 and your Fx to be 200. Now we have to determine what? F. To answer the question there. Ne? To answer the question there. Do you get it? To answer your question there. Ne? What can we use? Very easy. Begisa yona Pythagoras yalena yo. Pythagoras yalena ile creating F ile lembudzing or again F. Begisa Pythagoras. You said it again yourself. We're going to use the Pythagoras. And get, yeah, theorem of Pythagoras. You don't just add them. Theorem of Pythagoras. Guys, there's a 90 degrees here. And get, there's a 90 degree there. You have 100, you have 200. Please use a proper theorem of Pythagoras. So, yeah. Yeah, so it's going to be f, it's going to be root 100 squared plus 200 squared. Ne? It's going to be how much? It's going to be how much? What's going to be? The answer is going to be what, guys? What's going to be the answer here? Lena alitshware di-calculator lena. Alitshware di-calculator. Oh, 2223,61 newtons. Thank you. Yeah, 223,61 newtons. Thank you very much. Thank you very much. All right. Now, let's do the real stuff now. Now, let's do the... Now, let's do equilibrium, ne? Any questions, guys? Are you happy, guys? Are you okay? Are you understanding? Am I speaking air? I'm blowing hot air. Hapa you should say, Horese. You are blowing hot air. You should say it. If I'm blowing hot air, do we understand each other again? Hey, electrostatics, I'm not sure. I don't want to lie to you. I'm not sure. Are we okay so far? Oh, you don't... Okay. So... Alright, thank you. Thank you for those ones. Now, please tap the screen to 15K. Which part didn't you understand? Please be specific. When you don't understand, please make sure that you become specific. We are looking at the comment section there. If you are having problems, I'm going to make sure that I pin. Ne? So we are having excuse my drawing. Ah. You know, Monto, someone take now, guys. The question here is very simple. Ne? The question here, it is very simple. It's for us to determine the mass with this information that we are having on the board. Ne? With this information that we are having on the board. You get it? So, we are going to determine force M here. You get what I'm trying to say? But firstly, we are going to start by drawing the vector diagram, but I'm not going to give you this on the silver plate, right? So, what's going to be the value of T2, guys? What's going to be the value of T2? Who can tell me the value of T2 here? What's going to be the value of T2? We are having one answer. What's going to be the value of T2? Sorry. The value of T2 is going to be 245, guys. You get it? It's one tension. It is a tension, guys. This is one rope. You get it? It's one rope. Like this rope and this rope. There is no difference. You get it? Pella, you can even say, Hori, even here, it's Ty. You get what I'm trying to say? And this system is at equilibrium. Right? All the forces are balanced. Right? So who can tell me, can we break this T2 into components? Yes or no? Can we break this T2 into components? Can I get a yes? Can I get a no? If you disagree, or if you agree, can I get a yes? Can we break this T2 into components? Thank you. We can, right? We can. Because if I were to draw the free body diagram, that T2, it can be broken down. Tell me about the direction of the x component. The direction of the x component of T2 is going to point in which direction? It's going to be in which direction? The x component of T2 is going to be in which direction? It's going to be in which direction? The x component of T2 is going to be in which direction? Yes, it's going to be at eastward. Because of check. If I were to move my hand, obviously I'm going towards the east. Can you see that? I'm going towards the east. I'm going towards the right. I'm following the arrow. So it means that I'm going in an eastwards direction with an fx. What about fy? Tell me about the fy. Let's talk about the fy here. Is the fy is like, in which direction do we have our fy at? Thank you very much. You can see I'm going towards the east, and at the same time I'm going upwards like that. You see that? So this is going to be my fy. Don't be confused about the directions, please. You get it? Now, obviously, I'm going to have my T1. You get it? And remember, the system is at equilibrium. What do we expect here? What is fx going to be equal to? at the back of your head. What is fx going to be equals to? What is fx going to be equals to? Which force is going to balance fx? Which force that is going to balance fx? Which force? Thank you very much. It's going to be T1. T1 and Fx, they have to be equal. Because remember, this point, it does not move. This point, it does not go to the left or it does not go to the right. It's like having a situation like this. If I push this, F1 with 10 newtons. If Thabiso, wherever you are, if Thabiso comes, how much force do we have to apply here so that this box doesn't move? As currently the box is moving to the right. So if Thabiso comes, how much force does he have to apply to this box so that this box doesn't move? It stays in the same position. Which force? It's going to be 10, guys. It's going to be 10 newtons, but in the different direction. And then the box, it will remain in the same position. Same applies to here, right? We are having this T1 being pulled to that direction. But we are told that this system is at equilibrium. It means that force, that point there, it remains in the same direction. It remains in the same direction. It means there must be a force that it must be there to resist T1, but in such a way that this point, it doesn't go to the left and it doesn't go to the right. It means Fx has to be equivalent to T1 but in opposite direction. I'm not sure, guys. Am I making sense? Am I making sense? Am I making sense? Or am I blowing hot air? I'm blowing hot air. Oh, thank you very much. So now what am I going to do? I'm having T2, right? T2 already is going to be 245, right? This T2 is going to be 245. Now let's talk about the vertical direction. What is the force? I need you to guess this force. I'm not going to tell you what is the force that is going to be applied here. So I want to know what is the force that is going to be used to resist the Fy of T2. What's going to be the force that is going to be used, that's going to be plugged there, which is going to resist, which is going to oppose the Fy there? What is the force that is going to be used to balance Fy there? Thank you. It's going to be Fg. It's going to be Fg. Or you can say the tension downwards. So it's going to be, but for now, for the sake of argument, let's use Fg. Right? Fg is going to be the force that is going to balance this Fy. Do you see that? Because of the force that only goes upwards is Fy, but the system is not moving. It means this point, it is balanced by Fg. I hope you understand the concept of this, guys. I hope you understand the concept of this. You get it? So you can be asked, guys, you can be asked maybe in an exam, what is holding T2? T2 is broken down into components. Fx and Fy, these are the components of T2. These are the components of T2. Fx and Fy, or Tx and Ty, these are the components of T2. Guys, because here is my T2. You get it? The T2 is at an angle. It means it is applying the force on an horizontal direction and at the same time in the vertical direction. Do you see that? And you can be asked, guys, you can be asked. They would say to you, draw a closed vector diagram. Now, these are the marks that you shouldn't lose whenever you're dealing with such systems. Anger. So, tell me something. What is going to be this force? What is the name of this force? I'm going to break the structure down. Ne? I'm going to break vector, mara in different positions. I need the name of this force according to the diagram. What's going to be the name of this force? What's going to be the name of this force, guys? Batungara a final answer. Final answer. Which tension? Be specific. Which tension are you talking about? We have tension. Which tension are we talking about? Don't be smart. Which tension? This force is going to be T1. Right? This force is going to be T1. It's going to be this T1. This is one rope. This is one rope. So this T1 and that T1 is the same T1. Do you get that? Thank you. So what is going to be this force? What about this force? What about this force? What about this force? What kind of a force does this vector represent? Let's talk about this force. Check the diagram and tell me, what is this force? I'm breaking. Why one? Yes, it's going to be T2 because of T2. It is pulling away the strain, right? It is pulling the point, to the right. And get this T2, it is pulling the point to the right. This T1 is pulling the point to the left. Do you see that? So we are having this T2 pulling in that direction, this T1 pulling in that direction. And what about this force here? What about this force? What is this force? What about this force? Thank you. It's going to be FG. Right? Right? Now, this is T2. This is FG. This is T1. Anger. Now check this out. Ne? Now check this out. I'm going to take this force and put it here. Why one? I'm drawing a what? A closed vector diagram. Why one? I'm drawing a closed vector diagram. Now I'm taking this force, which is my T2. Why one? I'm taking it and I'm putting it here. Why one? Then obviously I'm going to have my T2 here. Why one? It's in the same direction. Why one? T2, right? And we said that this one is T1. What's going to be this angle? What's going to be this angle? What's going to be the size of this angle? What's going to be the size of this angle? 30. 1 kilo high. Now, I'm taking this force of gravity and I'm putting it here. Where one? I'm taking this force of gravity, I'm putting it here. So I'm going to have this. This is not a head, like it is a head to tail, but it is a closed vector diagram. Because if you can see, like this thing is like, it's like that. Like what? It's like, you get what I'm trying to say? It is different than the head to tail that we normally use. No. I'm not sure if you understand it. I'm not sure if you understand what I'm saying here. Do you get it? Do you get what I'm saying here? Like twara this part. Are we holding it? Right, are we understanding each other here? Thank you very much. Right? And now we are done drawing the closed vector diagram. The beauty about the vector diagram, guys. The beauty about the vector diagram. It is a fast process. It is very fast and it is very convenient. More especially if you mastered it. Now, we are done with this question. I'm erasing it. Now I'm going to which question? I'm going to determine the magnitude of T1. You get it? So tell me, according to the diagram that we have on the board, what's going to be the size of T2 again? What's going to be the size of T2 again? Oh, yes. Thank you very much. Thank you very much. This is the 90 degrees. Thank you. Thank you very much. So this is going to be the FG. Right? What's going to be the size of T2 again? Thank you. It's going to be 245 newtons. Again. Thank you. It's going to be 245 newtons. So, can we get T1? Yes or no? Can we get T1? Can we get T1? Can we get T1 according to the information that we have? Thank you. So how can we get T1? How can we get T1? How can we get T1? T1, we are going to use trig ratio. Thank you very much. So what kind of a trig ratio are we going to use? What kind of a trig ratio are we going to use? Thank you very much. We are going to use cos, right? Cos 30, right? Am I wrong about the cos? It's going to be cos 30, which is T1 that we are looking for, all divided by what? It's going to be divided by 245 newtons, right? And what is going to be the value of T1? When I do physics, I don't do maths. You're the one who's supposed to do maths. Now my job as a physical scientist or whatever, it ends here. What's going to be T1? T1 is going to be how much? T1 is going to be T1 is going to be 30 cos 30 times 4 2 whatever. Yeah, you can write it like that. It's fine. You are very correct. I'm not disputing it. Don't worry. What's going to be the answer here? I just need an answer. 212,18 newtons, right? Then can we get? We are done with this one, right? T1 is gonna be 212,18 newtons, right? So it means over here we are having how much? 212,18 newtons. Anger, we are having 212,18 newtons. We are done with T1. Now what am I looking for? Another question comes now. Determine the mass of the, is it crate? I don't know how to spell the crate. The crate. Right? Now we have to determine the mass of the crate. So, what is the first thing that we are going to do? Or the box. Yes, thank you. What is the first thing that we are going to do? We have to figure out FG there. Ne? We have to figure out our FG there. Ne? Is this the mass of the box? Yes or no? Erike check something. Is this the mass of the box? Is this the mass of the box? Yes or no? It's not the mass, ne? Thank you. Thank you. Yes, you can use a theorem of Pythagoras, or you can do a fast track. You're still not restricted to use the what do you call this? The trig ratio. So which trig ratio do you think we should use? We can use which trig ratio to get the mass, to get the force here? We can use, it's the same thing. It's the same thing. Because if I were to determine T1, I'll multiply both sides with 2, 4, 5 and times 2, 4, 5. But here, if I multiply this and that, they cancel each other. It becomes the way you've written it. It's just math, man. It's just a math. It's just a math. So here, guys, I can use sine 30. Am I lying? Am I lying? I can use the sine 30, right? Thank you very much. So what am I going to do? I'm going to say sine 30 is going to be opposite. What's going to be my opposite? It's going to be FG. It's going to be FG. So FG is going to be what I'm looking for over what? What's going to be over 245, right? What's going to be the size of my FG? The size of my FG is going to be half this guy. Ne? What is half 245? I think it is 122.5 newtons. Ne? It is 122.5 newtons, if my math serves me right. And it's gonna be downwards. Right? Then, are we done answering the question? Yes or no? Are we done answering the question? Huh? Are we done answering the question? Are we done? Thank you. We are not looking for the force. We are looking for the mass. Right? So which formula do we supposed to use in order for us to determine the mass of an object? What formula are we supposed to use in order for us to determine the mass of an object? We are going to use what? F net is equals to MA. No. Yes, we are going to use FG. It's going to be equals to MG. Not F net. Guys, this is Newton's first law. These are forces at equilibrium. We don't, no. So, since we are having FG is going to be equals to MG, I can simply remove this and put MG there. So what's going to be the value of the G? What's going to be the value of the G? What's going to be the value of the G? The G is going to be how much? 9.8. M multiplied by 9.8 is going to be 122.5. Ne? Then divide by 9.8, divide by 9.8. This and that, they cancel. Then what is 22.5 divided by 9.8? What's gonna be my mass? What's gonna be my mass? Oh, my mass is gonna be 12.5 kg. What a wow. What a wow. The mass is going to be 12.5 kg. Nice and simple. Very nice and simple. My one. The mass is 12.5 kg. So guys, are we getting it? Is it understandable? Is it fine? Eh? Is it fine? Aye. Many mnandi ngimnandi, many mnandi ngimnandi. Yes, you can still use the theorem of Pythagoras to get the FG. You're supposed to get the value. It doesn't have to be exact. It can give you 22.4 something, or fluctuating, but as long as the value is closer to this guy here, I don't see any problem there. So now let's do it. I have another question. So yeah, I'm not again. Okay, now I want us to talk about now I'm doing the teaching now. Yes, it's 22.49. Round off into the one decimal place, it's gonna become 22.5. I told you we are going to get a value that is closer and closer. Right? So like let me do the teaching now. Let me do the teaching and the understanding and get. So guys, I want us to talk about the Newton's first law. First law. Yeah. Now, as we talked about the object moving at constant velocity. So, I want us to understand something. Let's talk about friction. The topic of today is friction. So, we have different types of friction. We are having a static friction and the kinetic friction. Did you know that? Yes or no? Did you know this stuff? In other ways, guys, I'm checking Hore, have you done this stuff at school? Did you do this stuff at school? I'm checking Hore. Did you do this stuff at school? How many of you? I want to know Hore, how fast can I go? All right. Okay. Now, we are having a yes and some of the no's, and which is fine, right? So now, if I'm trying to push, let's say you're at home, you are trying to push the wardrobe. This is your closet, what? And when you're trying to apply a force here, and the force is going to be equals to 10 newtons. Okay. Obviously, right? The what do you call this? The wardrobe. It's gonna be tough to move, right? But let's say you are pushing this wardrobe and it doesn't go anywhere. What kind of a friction are you experiencing in this case? What kind of a friction are you experiencing in this case? Is it static? So why is it static? Why do you say this is the static friction that you're experiencing there? Why do you say it's a static friction? Why do you say it's a static friction? I want to know why do you say it's a static friction? Oh my goodness. It is stationary, right? It means the whole drop, it doesn't go anywhere, right? Thank you very much. Ne? Please, can I be patient? Can you please be patient with me? There's the question that I'm looking for here. But I can't get it. I don't know why. I don't know why am I not getting this question. Okay. Now, what about whenever you are having an object and if you're pushing it, it moves. What kind of a friction are you experiencing there in this case? Now the object, it is moving to the right. What kind of a friction are you experiencing there? Is it kinetic? Why do you say it's a kinetic friction? Why do you say that it's a kinetic friction? Because of its moving, right? That's the difference between the two friction. It's fine. I don't find even the question, but it's fine. I don't find even the question. Let's go back here. Now, let's go back here. Okay. Okay. Oh, here is it, yes. Now, okay. Since we are okay, guys, ne? Sorry about the whatever that you might call. So, hey Mara, thanks for your patience, guys. Thank you. I really appreciate your patience. So, guys, static friction, it is the maximum it is the maximum, it is the tendency, it is the maximum friction force that opposes the tendency of the motion of the stationary object relative to the surface. Well, so it means if you apply a force here, guys, ne? If you apply a force and this object, it does not move. Do you get that? This object, it has a tendency of going to the right, but it still doesn't go to the right. I'm not sure I'm making sense in this part. And get that's why I want to make sense with this equation, because for me, like, the definitions are very important. So this frictional force, it opposes the tendency, because of, you can see where this object, if I'm pushing this object to that direction, this object, it has a tendency of going to the right, but it doesn't go to the right. It remains stationary. It means the friction here is going to be what? is going to be at maximum. You get it? Because of if this friction it is opposed, if this friction it is overcome, if this friction it is overcome, it means that the object it will start moving. Am I making sense, guys? Does it make sense? If this friction it is overcome, it means this object it will start moving. So now this type of friction it will no longer be Fs. But if you are pushing this object you are pushing it, right? Maybe let me make an example with the board. The board is going to the left or to the right? But if I'm pushing this board, you see I'm pushing it, this board it has a tendency of going to that side. You get what I'm trying to say? It means with this board it is experiencing it is experiencing the maximum frictional force. It is experiencing the maximum frictional force that opposes the tendency. It opposes the tendency of motion. So it opposes the movement in that direction. But the moment I apply more force, it means that I'm overcoming the friction. I'm overcoming this F static. And if I overcome it, the board starts to move to the right. So now, if the board it moves, it means that it no longer experiences the Fx. But now, if this object it moves with a certain velocity, now the type of a friction that is going to be represented here is going to be what? What's going to be the type of a friction that we are going to have there? What's going to be the type of the friction that we are going to have? If now the object if the Fs it is overcame, one good is the type of a friction that we are going to experience there, it's going to be Fk. The Fk it is the kinetic frictional force. Do you see that? And then now it is no longer what? It is no longer a maximum frictional force. It becomes what? It becomes what? A minimum. It becomes what? A minimum frictional force. It becomes a minimum frictional force that opposes the what? Not the tendency. Now it doesn't oppose the tendency. It opposes the motion. It opposes the motion of, not of a stationary object, because of the object it is now moving. You get it? It opposes the motion of a moving object. It is opposing the motion of a moving object. You get it? The static friction, it is the maximum kinetic frictional force that opposes the motion of what? Of a stationary object. The object, it is stationary. Here, the object, it is moving. Do you get the difference, Mark? Do you get the difference? Here, the object is moving relative to the surface. Right? It means in order for us to have frictional force, in order for us to have frictional force, you can see at the end, relative to the surface. Relative to the surface. It means what do we have? What do we have to have? It is the surface required. Right? The surface, it is required. And don't tell me about air friction. Air friction is ignored all the time. Whenever you are in grade 11 or 10 or grade 12, don't tell me, what about air friction? It is ignored. On good reasons. but the surface, it is required so that you can have a static or kinetic frictional force. This is the difference between the two frictional force. Do we understand each other? Who doesn't understand so far before we move? Do we understand the difference between the two? You get it? Static friction, in summary, it is the maximum kinetic frictional force that opposes the tendency. It means you can push this, but it doesn't move. Whenever you push it, it doesn't move, but it means the friction, it is at maximum. The friction is at maximum because you're pushing it, it doesn't move. It means you're having the maximum kinetic frictional force. But the moment this object starts to move, it means now this Fs, it is overcame. Now you're experiencing a kinetic frictional force. The minimum frictional force that opposes the motion of the moving object. The object, it is now moving. It is experiencing a friction. That type of a friction, it is what? What do you call this? Kinetic frictional force. I hope I'm clear on that one. I will screenshot this and post it. Next time when they ask you to define friction and you fail to define, don't tell me who you were attending my lives. I don't know you. Or what? Don't tell me. Don't tell them where you I was attending TK's live. He said so. No, I didn't tell you. So let's continue now. We are having an object, right? Ne? Do right? We're still on first law, ne? And they're saying constant F pulls this object is experiencing the let me just say the coefficient of frictional force. The coefficient of the frictional force is 0.4, ne? And they came again and say that and they said that the object is moving at constant velocity. The object is moving at constant velocity. Now, determine number one. Determine the what? The magnitude of force F. All right. Okay. Guys, okay, let me ask you a question, guys. Are you guys familiar with the free body diagram? Can I get a yes or no? Are you guys familiar with the free body diagram? Okay, so far so good. So far so good. So far so good. Ne? Alright. Now, are we having a surface there according to our statement? Let me draw this structure very well. We are having a surface. Alright. Since we are having a surface, so we are having a surface. So it means we have friction, right? It means we have the friction. And it means we have the friction. You get what I'm trying to say? So let's draw a free body diagram. Let's draw a free body diagram, right? The first thing that I'm going to do, what can I comment about Fnet? What can I comment about the Fnet? The Fnet is equals to how much? What's gonna be my Fnet? What's gonna be the value of an Fnet? That's supposed to be easy. It's gonna be 0. Why is our Fnet 0? 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 It's because of the object is moving at constant velocity. You get it? Yes, all the forces are at equilibrium. Now, what's gonna be the value of my acceleration? What's gonna be the value of the acceleration? The value of the acceleration is gonna be how much? It's gonna be 0 Newton. 0. What is the SI unit of acceleration? The force is Newton, yes, but what is the SI unit for acceleration? Thank you very much. It's going to be meters per second squared. Now, guys, I need 25k likes. In the meantime, I'll be waiting for the answer of the force F. In the meantime, askera practice, guys. You are not here to look at me. Pelana, I'm not the show, guys. This is a training sessions on Kutusis. Even when you join my extra classes, I'm going to put you on the training session. You are going to be busy on Kutusis. I don't give answers on the silver platter. We are going to be busy, guys. And thanks for those, but I will respond to you once I'm done with the live. Once I'm done with the live. Bye-bye. Thank you for the gift. God bless you. God bless you. God bless you. With many more marks and distinctions. Marks and distinctions. Once I'm Have 25k likes. Please tap, please follow, please tap, please follow, please tap. Marks, ne? It's 7 marks this one. Ne? This is gonna be 7 marks. I'll do this question for you. The question: determine the magnitude of force F. There is no extra detail. You are having everything that you see on the board. Whatever, it's what you are going to have there. Everything that you see on the board is what you have. One time. Please make sure, please let's like the live. Let's like the live. Let's like the live. First F. No, that's very quick for you to get that answer. Why do you got that answer very quick like that? What's the answer? Tap the screen. Baba Jaba. 25k likes. What's the answer? Have you ever? Is there anyone who got the answer? I don't see anyone who's giving out the answer. What's the answer? Please follow the live. Please follow the live. Okay. Is there anyone who got the same answer? Is there anyone who got the same answer? No, let's do it. Okay, let's draw the free body diagram. What forces do we have here? What are the forces that we have here? Let's name the forces that we have. Okay. We have Fg. Thank you very much. Our friction is gonna be in which direction? Our friction is gonna be in which direction? Is gonna be on the left or is going to be on the right? My friction is gonna be on the right. Okay. West. On the right, right? On the right. West, okay. What kind of a friction am I having there? What is the type of the friction that I have there? What type of a friction that I have? This object is moving, by the way, ne? It's moving at the constant velocity. What type of an object? Yes, it's going to be Fk. The object is moving at constant velocity, so I'm going to have Fk there, right? And what else? We're going to have our normal force, ne? And I'm going to talk some more about the normal force, which is fine. And we're going to have what? Our force applied being in that direction, 20 degrees. And now I want to determine what? We have to determine the magnitude of F. This F. This is what we are looking for. Ne? That is the F that we are looking for, guys. You get it? So, is our free body diagram fine looking like that? Is it correct looking like that? Is our free body diagram fine looking like that? There is nothing that we left behind, right? Thank you very much. So let's see now. What is our normal? Is the normal equals to FG? Is normal equivalent to FG? Is our normal equals to FG? Is normal equals to FG? Are these two equal? Is this two equal? Are you serious? Okay. Those who are saying no, those who are saying they are not equal, why are you saying that FG and normal are not equal? I want to know that part. Why are you saying FG and normal are not equal? Why are you saying that FG and normal, they are not going to be equal? It's because of why? We are having the force F pulling the object in that direction. It means our Fy is going to point in which direction, guys? We have to add, okay? It means, let's talk about the Fy of this force. It's going to be in which direction? In which direction are we going to have our Fy? Up, right? So I'm going to have my Fy to point up, right? And what's going to be the direction of the Fx? Let's talk about Fx. It's going to be in which direction? My Fx now. Let's talk about Fx. It's going to be in which direction? To the right, right? Now, let's check. This is Fx, this is Fy, and this is Fx, right? Being in different direction. So let's take the sum, the F net along the y to be equals to 0, right? And let me just do this. I'm taking upwards as positive. So since my sum of Fy is going to be equals to 0, I'm going to put 0 on my left hand side because of this and that same WhatsApp group. So is my normal going to be positive or negative? No, is normal going to be positive or negative? According to my direction of choice and the direction of the normal. It's going to be positive or negative? It's going to be positive, right? It's going to be positive. Now, what about Fy? Is Fy going to be positive or negative? It's going to be positive or negative? Fy. Let's talk about Fy there and its direction. It's going to be positive or negative? It's going to be positive, right? And let's talk about the Fg. Since Fg is collinear to the normal force and the y component of force F. So y, the normal force, Fg is going to be negative or positive? It's going to be negative Fg, right? So if I take Fy and Fg and isolate the the normal force, I'm going to have Fy, okay, Fg minus Fy is going to be equals to the normal force. Do you get that? And remember, the force of gravity is going to be mg, right? Let's determine the force of gravity of that object today. So it's going to be 50 times 9,8, which is going to be how much? What's going to be the force of gravity there? What's going to be the force of gravity? It's going to be 490 newtons. I'm going to add 490 newtons here in place of Fg, and I'm going to say 490 minus what's going to be my Fy. My Fy in terms of F is going to be how much? Remember, my Fy in terms of F is going to be how much? My Fy in terms of F is going to be how much? My Fy in terms of F, remember, if I say sine 20, what's going to be the ratio there? Because the 20, it's opposite to Fy. So it's going to be Fy over F. Then my Fy is going to be how much? The Fy is going to be F sine 20. Then Fy is going to be how much? What is sine 20? What is sine 20, guys? What is sine 20? 0.34. So Fy is going to be 0.34 F. Then in place of Fy, I'm going to put 0.34 F, right? So it's going to be 0.34 F, which is my N, like that, right? I'm done with this equation. Ne? I'm going to leave it the way it is. Now, what is it that I'm looking for now? I want to look for friction. Ne? And how can I determine the frictional force? Using the coefficient. How can I determine the frictional force? Using the coefficient. Because of obviously, the coefficient of the kinetic friction is going to be normal divided by Fk minimum. Ne? Thank you. You get it? Or you can just no. It's gonna be Fk minimum divided by norm. The other way around. Then I can just simply multiply the two. Even this one is still applicable. Fk minimum is gonna be the coefficient multiplied by the normal. And this is the standard formula for calculating frictional force. This is the standard formula for calculating the frictional force. So I'm going to use this formula to determine the frictional force. So let's determine the friction. Right? So the friction is going to be how much? It's going to be Fk minimum. It's going to be what? What's going to be the coefficient? It's going to be 0.4. And what's going to be the normal? The normal, I'm going to write it in terms of this guy is over there. Do you see that? I believe we are following there. I'm going to write it in terms of those guys. So I'm going to say in brackets 490 minus 0.34 F, right? It's gonna be 0.34 F. Is everything visible, guys? Can you see everything here? Can you see everything here? Is everything visible? Do you see that? So now, what am I going to do? I'm going to distribute for this friction. Again, I'm going to distribute 0.4. What is 0.4 times 490? What is 0.4 times 490? Who can give me the answer there? What is 0.4 times 490? It's going to be 196. And what is 0.4 times 3.4 times? Thank you very much for your participation. So what is 0.4 times 3.4? What is 0,4 times 3,4? Oh, okay, it's off. So it's going to be 0,136. Is it 0,136? Okay. Going to be minus 0,136. Is it? Oh, okay. It's fine. 0,136 and 0,4 FK min. Now, let's take the F net along the X and see what is it that we are going to get. Oh yes, F, thank you. You get it? Let's take F net along the X axis and see what I'm going to get. And I'm taking the east side as positive. So what am I having in the horizontal? What am I having in the horizontal? What am I having in the horizontal? I'm having Fx, Fk, I mean. Fk, right? I'm having it on the horizontal because of it's along the x-axis. So is my Fk going to be positive or negative? Is my Fk going to be positive or negative? That's my question there. Is my Fk going to be positive or negative? It is grade 11 and 12. 11 and 12, yes. Eh? Come on, guys. I chose this direction as positive, guys. I chose this direction as positive. So I want to know if I chose right as positive, will my Fk be positive or negative? Simple question, guys. Simple question. Will my Fk be positive or negative? If you don't answer, we don't move. If you don't answer, we don't move. What's going to be Fk? Negative or positive? Oh, guys. So no one was paying attention. I chose right as positive. Guys, I chose right as positive. Now, I want to write the F net along the X. Obviously, it's going to be 0. So 0, I want to know, will my Fk going to be positive or negative? Since I chose my right to be positive, I want to know my Fk, is it going to be positive or negative? Or maybe the question is very tricky, I don't know, but it's fine. Let's do it. Where is this Fk pointing? Is it pointing to the left or is it pointing to the right? This Fk. Is it pointing to the left or is it pointing to the right? So where is my direction of choice? Like, where is my direction of choice pointing to be positive? This is my direction of choice. Where is it pointing? Where is it pointing? It's pointing to the right or east, right? Look, the friction is pointing to the left. The direction of choice is pointing to the right. And I chose the direction of right as positive. So how will be my Fk? So since Fk is pointing to the left and my direction of choice is pointing to the right, and I command it to be positive, right? And I command right to be positive. So my friction is going to be positive or negative? That's what I'm asking. You still don't know. It's going to be negative. Guys, fk is pointing to the left. You chose right to be positive, so you're going to have negative fk. What about fx? Is fx going to be positive or is going to be negative? The problem is that you don't try. That's your problem. You are afraid to make mistakes. Life doesn't work like that, guys. You are so afraid to make mistakes. And in this life, it's not like if you got the answer wrong, I'm going to judge you. I'm not going to judge you. I'm here to help you. You get it? So now, what am I going to do now? So I'm having negative fk plus fx. And so how can obviously I have my fk in terms of f, and how can I write my fx in terms of x? How can I write my fx in terms of f? How can I write my fx in terms of x? How can I write my fx in terms of x? So check. Now, I'm going to say what? I'm going to say cos 20 is going to be equals to what? Cos 20 is going to be equals to what? Cos 20 is going to be equals to fx adjacent over hypotenuse. Fx over hypotenuse. Do you see that? And my hypotenuse is going to be f. Multiply the two, and I'm going to say fx is going to be f cos 20. And what is cos 20? What is cos 20? What is cos 20? When you punch in your calculator and you say cos 20, what is it going to be? What is it going to be? What is it going to be? Fx is going to be 0.94 f. Do you see that? 0.94 f. Now, I have this equation here. I have my fk and I have my fx. So what is my fx? My fx is going to be 0.94 f minus 196 minus 0.136 f. Do you see that? It's going to be equals to 0. This is going to be distributed, and this is going to be 0. And what's going to happen? I'm going to have 0.94 minus 196 plus 0.136 f. Well, one. Then what am I going to say now? What am I going to say? I'm going to add this and that. What is it going to be? If I add 0.136 and 0.94. Is it 1.076? So, hey, wait. Okay, now it's going to be it's going to be 0.94. Man. What is it? What is the answer again? 1,076. 1,076 minus 196. Then I will take this guy, F, ne? And I'll take this guy to the other side, and I'm going to have 196. It's gonna be 1,076 F. Then what's gonna be the value of F? What's gonna be the value of F? I know it's 7 marks, guys. This question is 7 marks. It's gonna be 181,65. It's gonna be 181,65 newtons. 182 or 181. What is the answer, Kant? Is it 181 or 182? Is it 181 or 182? It's gonna be 182,16. Because the scale we are going to divide both sides with 1,076, 1,076, and this and that. When they cancel, it's going to be 182,76, 16, I mean, newtons, which is F. We. One. So yeah. This is the physics. This is physics. This is physics, guys. Then any questions? Any questions? Any questions? Did you understand, Marie? Did you understand? I started at 3 o'clock. I think 3:30 or 3. I'm not sure. Yes, I do from 10 to 12. I do physics from 10 to 12. So this is our F. Ne? And guys, when you substitute F here, how much does it give us? No, wait. FK. No, I need FK. Where is my FK? Oh, FK is this one. 19. So when you substitute F here, how much does it give us? If I substitute 182,3, how much does it give us? Surely the fraction is going to be that guy. The one. We are going to get this guy here by substituting this answer here at this formula. So how much do you get whenever you substitute this answer here in this formula? Because the following question, they are saying we should determine the normal force and the frictional force. Already we have the two formulas of normal and friction. Ne? Is it negative? What? It's not supposed to be negative. I totally disagree. How much do you get, guys, when you substitute the friction here? How much do you get? Yes. 171. And when you substitute the very same f in fx, where's my fx? Here's my fx. My fx is gonna be 0.94 times f. If you substitute 0.94, wait, you said your friction is how much? You would like to join? You said my fk is how much? Ngana, you said my fk. This is fk. Fk mean you just substitute the value of x, this one here, then you get your friction. I want to compare something. I want to compare something here. Oh, it's 171.23 newtons, right? Okay, 171.23 newtons. So when we substitute fx in place of fk, so here's my fx. I said fx is 0.94 f. So what's gonna be the value there when you substitute fx with 0.94 f? It's still 1.3. Because remember, the system is at equilibrium, right? If you remember very well, it's moving. So if we get fk is 1.3, fx is 1.3, correct on the spot. We understand each other. It means where everything is pashash. It means when you got 182.16, you got a correct answer. You can go, the ones who believed in the memo, go to your memo. Here we are not using the memo here. We are not using the memo. We believe in our brains. We believe in our brains. You have to see the mistake by yourself. You have to make sure that you see that mistake by yourself. Don't wait for the memo to verify your wrongdoing. Because of even the memo, it was designed by the person. Try to understand the concept behind physical sciences. Hey, I'm kidding. You can go and confirm with the memo, but I don't like using the memo personally. Memorandum, it makes people to not to think for themselves. Like, it makes you to be lazy. You will never do these critical calculations if you don't have, like, if you have a memo. It's like using an AI over everything. Everything you want to use an AI verification. Whenever you write an email, you use an AI. Whenever you write your CV, you use an AI. You will never be smart. I'm telling you now. Try to challenge yourself and make sure that you are within the borders of physical sciences. Is that clear? I believe long zwile. Then thank you very much for tuning in. Please guys, make sure that you join my private sessions, make sure that you join my private sessions, and make sure that you inquire, and make sure that you tune in as early as it is now. Now it's still February, I believe, or it's still early. We can have this journey. When can I come for grade 12? Maybe tomorrow. But I like hosting grade 12s on weekend because of most of the learners who are doing grade 12s, they are not here. They are not here. By the time I start this live, most of the grade 12 learners are not here. And why am I doing this is because of like basics are very important. Because of if you are a matric learner watching this live, you will learn a lot. And there are some things, like there are so many things that you can learn here which they can work for you on, maybe when you are doing whatever the topics that you're doing in grade 12, work energy and power, vertical projectile moment. As long as that you're doing mechanics, as long as you're within mechanics, this guy, as long as you are within mechanics, each and every information is important. So guys, thank you so much for tuning in. So if you are interested in joining my private sessions, you can DM, and please don't forget to like and share and follow and like and share and follow and like. I don't know, Solve for X will solve him tomorrow. Maybe if tomorrow I go live, surely it's not going to be physics, it's gonna be maths. So thank you very much, guys.